Hello there, my name is Sajan. So today I'm going to explain you about a big data project that I recently did. So if you are someone who is interested in big data or cloud computing, then this might be something very useful for you to get started. So for this project I'm going to use COVID-19, which has been the highlight of this year. So for here, let's quickly look at the architecture that I have built. So to start with, in the left side we have the input, and we have two types of input here. So first is the Twitter data. So for this we require a Twitter developer account. um, so you have to apply for it if you were to test a similar setup, or if you have a use case that needs to analyze tweets. And to get the data to the S3 bucket, we are using something like a Kinesis firehose service. So that will take the tweets, and that will do some aggregation and then write to the S3. Similarly, we have another data source, that is the Github Data. Basically, it is available here in this repository, and it is maintained by the Johns Hopkins University. And this provides stats about COVID-19 across the world, and it is updated in a daily basis. So it is a very handy data source to analyze for in this project. Then after the data is available in our S3 bucket, we would have our actual application, which is Spark, that will read the data from S3, process it, and write it back to the S3 in a different location. And for Spark, we are going to use the Python implementation, also known as PySpark. I will walk you through the actual code and the logic in the later video, but for now, let's just focus on the overall workflow. Then, as I mentioned, the GitHub data comes in a daily basis. So to process them in a daily basis, we are going to use something called CloudWatch Rule. So we'll define a cron expression, and then the CloudWatch rule will be triggered in that time, and it will then invoke a Lambda function. And then this Lambda function will be our main scheduler, and it will be responsible for submitting the job to the EMR cluster as a step. And before it does that, it also has some additional logic to check whether the job has already been completed, and if so, it won't submit it because that would be a duplicate. Or if the job was in a failed state or was stuck in a running earlier, then it will check for the corresponding EMR step and determines whether it should submit the job or not. So this is very helpful in terms of scheduling, and also to prevent any duplicate run of a job. Additionally, since Lambda function publishes their metric to CloudWatch and also logs to CloudWatch, then if something goes wrong, it becomes very convenient to troubleshoot those metrics and logs. Similarly, after the job is submitted to the EMR cluster as a step, then it will start executing once it gets the required resources from Yarn. So both PySpark job in EMR and the Lambda function, they write their results to DynamoDB. So basically this is like our checkpoint for our jobs, so that we are keeping track of which jobs are completed or what is their current status. So in real time, for example, when the Lambda function submits the job, it will write an item to DynamoDB table saying that, okay, I have submitted an EMR step, and these are the cluster parameters, step ID, and the date. Similarly, once the PySpark starts executing, it also updates the DynamoDB saying, okay, for the previous item, it is now in a running state. And similarly, when it completes or failed, it updates the same in the DynamoDB table. Next, from the DynamoDB table, we'll have a Dynamo stream enabled on it. So once something gets updated in the table, it will write that update in the stream, and then we'll have a trigger from the stream to invoke a Lambda function. This Lambda function will be mainly used for notification purpose. So after the DynamoDB stream invokes the function gets the updated item information, and then it builds a notification message and then publishes it to the Chime. So for Chime, we have something like a webhook URL that is specified in the function so that it knows where to push the notification. And if Chime is your daily communication tool, then this notification becomes a lot more easier to manage and monitor. So to give you an overview, so this is my Chime channel where I am pushing those notifications. As you can see, for example, it is scheduled at 8 a.m. and when the Lambda function submits the job, it sends this notification, and then when the PySpark starts executing the job, it changes to running state. It also gets the application ID, other information like user and queue. Similarly, when it gets completed, it pushes the another notification saying the job has been completed and here is how long it took. All right, so this is just an example. You could tweak it further to match your requirements. So that will be for the processing part, and at the end of this project I will also show you like how to utilize CloudFormation to deploy this whole setup in a stack. And then in the EMR we also have glue catalog for Hive metastore. So you could also use the internal Hive metastore that is inbuilt in the EMR, which is based on the local MySQL server. But since I am planning to use the cluster as a transient cluster rather than having it as a long running cluster, I would like to separate my Hive metastore from the cluster so that when the cluster goes away, I don't want my metastore to go away also. So for that, I'm using external metastore, and Glue Catalog is a very good alternative for that. If you have some other requirements, you could also go with MySQL Server in RDS, for example, and you could do a similar setup. And since I'm using Glue Catalog to store my metadata, I can also easily integrate with Athena. For example, using Athena, I could easily query my data in S3 to analyze the result data from my PySpark jobs, for example. Similarly, Athena also has native integration with QuickSight, which is a data visualization service. So from QuickSight, I can also use Athena as a data source, which is again backed by S3 and Glue Catalog. And from here, I can create analysis and dashboards to create several graphs based on the result data from my pipeline. And this part is optional. For example, in my case, I am creating a dashboard that can be embedded in a public website. That's why I'm using this. So if you have a similar requirement, you can follow this, or you can ignore this part also. So my goal here is to, like, for example, create a dashboard like this. So for example, it is publicly available and it gets updated every day as the new data comes in. So if you have a similar requirement, you can go with it. And for that, I'm just using a Lambda function which is responsible for generating a QuickSight dashboard URL. So it will just make an API call to QuickSight. Similarly, I have API gateway. So this is a bridge between my function and my S3 static website. So my website, once it is loaded in a browser, it will use Ajax to call API gateway. Then API gateway will invoke Lambda function, which will then in turn call QuickSight to generate the URL, and then the URL flows back to the browser, and the browser will finally load the URL and then embed it in our website. Okay, so that is the overall architecture. So in the next video, I'll walk you through the each setup, like how my job is configured, how the notification is configured, and also how I am using QuickSight to generate my graphs so that you can get an idea about how to get started. Okay, till then, bye.